Hi guys, welcome to my channel. Today we are going to solve the questions about the structure analysis, and we are going to use the slope deflection method. And now you can see that we have a beam. We have three supports, two is fixed, one is a roller. So let's solve the question. And the first I'm going to start with specify the fixed and moment values because it's important that the first we are going to specify them. So for AB, fixed and moment AB is equal to PL over 8, 25 times 6 over 8 will be equal to 18.75. For FEM, and fixed and moment for BC will be equal to WL square. W is 15, L is 4, so 4 square over 12, that will be 20. 20 kilonewton meter. This is the moment, fixed and moment. For fixed and moment BA will be the same, but that will be, you'll take as this is going to be minus, this is going to be positive, because you know that the fixed and moment is clockwise is positive. And this is going to also be negative, and CB will be equal to 20 kilonewton per meter. So let's start with calculating the moments. Moment AB will be equal to 2EI over 6L and times 2 theta A plus theta B minus 3 delta over L. And of course I'm going to take as my FEM is 18.75. For moment BA, 2EI over L, 6 times 2B, 2 theta B, plus theta A minus 3 delta over L, and plus 18.75. So for the moment, now you can see for the moment BC, that will be 2EI over 4, because the length of the BC is 4, and times with 2 theta B plus theta C minus 3 delta over L, and that will be minus 20, because you know that I told you the clockwise direction is positive and our counterclockwise is negative. So moment at CB, 2EI over 4, 4 times with 2 theta C plus theta B minus 3 delta over L. That's plus 20. So now you know that the both side of the beam are fixed, so we don't need to calculate theta A, and theta C, because there will not be any deflection, and we don't have any settlement also, so we don't use delta also. So now you can see we just have two equation and one unknown, so we can solve it. You know that in in here at B support, the both moments, moment BA and moment BC, this couple moment, the summation of that must be 0. So if I take the summation of them and I make it equal to 0, and I am going to specify theta B. So moment BA plus moment BC equal to 0. Let's take our equations. So times 2 theta b over 6. Now 1 second. 6 and plus 18.75 and plus 2 EI times 2 theta b and over 4 and plus minus 20 equal to 0. From this, I'm going to take like that 0.67 theta b, of course EI, plus theta b EI. When I cancel with this, also, I will have a 3, 1 over 3, then I'm going to take this one. Okay, so now that will be equal to 1.25 when I take this both and take the minus the other part of the equation. And now the theta b here will be 0.75 over EI. Now I solve and I find the theta b. So let's find the moments. When I put the theta b in the equations, in the moment equations, I'm going to determine the moments. So let's do it. That will be 18.5 kilonewton meter, and this will be 19.25 kilonewton meter, and this will be minus 19.25 kilonewton meter, and this will be 20.375 kilonewton meter. So now I specified the moments. So let's define the shear and draw the moment and shear and moment diagram. So how I'm going to do that? Well, let's solve this one. For example, this is A and this is B. We have VB left and we have VA, and I have a moment like that minus 18.5, and this is the moment here, that will be 19.25, right? And I have a force, it is the half of this. This is 3 and this is 3 and this is 25. Okay, so I'm going to text like that. I'm going to say that the moment at A equal to 0. So how I'm going to solve it? I'm going to 18.5, and minus 25 times 3 minus 19.25 and plus VB left times 6, right? If it is equal to 0, so VB left will be equal to 63. So for the total Fy is equal to 0, so I'm going to take 25 minus 12.63 minus VA, and VA will be equal to 12.37. So now I specified for the first, so now let's do it for the second part. The second part is also we have, this will be B, this will be C, I have VB right, and I have VC here, okay? And I have a distributed load, so I'm going to convert it to point load, so you get 25 times 4, 15 times 4, it's going to be 60 kilonewton. this is 2, this is 2, this is 19.25, and this is 20.375. So I'm going to do the same thing for here. If I write here moment at B is equal to 0, so that will be 19.25 minus 20.375 minus 60 times 60 times 2, and of course plus VC times 4. So this is equal to 0. So VC will be equal to 30.28, and total Fy is equal to 0. In this equation, I'm going to take like that: 60 minus 30.28 minus VB right. Okay. In this question, like that, VB right will be equal to 29.72 kilonewton. These are kilonewton. So now you can see I find the shears and I also know the moments. So now I can draw the moments diagram and shear diagrams. So let's draw them. Now I'm going to draw the shear diagram here. This is going to be my shear. Okay. Now I have a support here, roller. Now I have fixed also. Now I will, now at the B, for example, this is B. This is, sorry, AB, this is C. At A, what is the value of the shear here? 12.37, right? I will come until the force that acts. What is the force that acts? Sorry, this is 12.37. The force is 25, so I will come down. I will come down as 25, and I will, oh sorry, 1 second. I got a problem with drawing. It's not something like that to draw in the book. Sorry, 1 second. Like that, and I will go up, and I stop here, right? This will be 12.63, because I'm going to take the subtract from the 25. So I will take the 12.63. And then I have at B. At B I have the shears. What is the summation of the shears at B I have? The summation of the shears, let's calculate it 1 second. This will be 29.72 plus 12.63. 12.63, that will be 42.35. I will take minus 12.63. Then I will reach in that place, I will reach 29.72. I guess, yes, it's beautiful like that. Now I have a distributed load here. If it is distributed load, that will be a triangular decreasing. So I have a 60 triangular decreasing. I will take the, I'll subtract from the 60, and I will reach that point. That point will be 30.28. Now this is my shear diagram. Now I have to draw the moment diagram also. Now let's draw the moment. Now, sorry, I can't draw the straight line. And this is A, this is, we can say B, and this is will be C. You know I have a moment at A, right? A moment at A. I will take as 18.5. 18.5, I will come straight, and I have to take the area of the shear diagram from A to until the force it acts. So that will when I take the area of this shape, and I subscribe, and I take the negative of this one, that will come to the until that force. The force is X, that will be 18.62. And I will get down, because you know, if this is positive, for example, this is negative. If this is positive, this is negative. If this is positive, this is negative. If this is negative, this is positive. So I will take it, the area of that, I will take the subscribe until this point. That will be 19.25. And now I reached this point. At this point, now you can see I'm going to take the area of this n. That will be, for example, 29.72 over the area of this moment, this area of this triangular. It will reach, for example, at this point, for example. It will reach at this point, and the area of that triangular, it will decrease me, and I'm going to decrease, and until that point. That will be 20.37. Thanks to watching my videos. If you want to see more of the videos, please subscribe and share and comment. If I have any mistakes, I'm going to try to revise and try to be better for the next questions. Thank you for watching me. See you for the next question.